I am Areg Mikaelian, an astronomer, which is the best representation of myself. Usually people like to name some titles, some positions, but this is nothing compared to the main profession, which is astronomy, the best profession in the world. But anyway, I work here since 1986, since the early years, and then I had all my career in Byurakan Observatory, of course also working from time to time abroad in different countries, mainly in France, Germany, Italy and USA. I had good collaborations, and for many years I traveled usually at least 3 months. I spent abroad in some of these institutions of some of these countries. Namely, I worked in Observatoire d'Haute-Provence in France, which is one of the famous, which is one of the biggest telescope in France. There are two meter, one in Pictumidi and the Observatoire OHP, as we call. Then in Lyon also, Kral, then in Paris, in IAPE. I visited many other observatories and universities like Strasbourg, for example, the biggest data center in Europe of astronomy. In Germany, I worked in Hamburg Observatory, in Potsdam, in Heidelberg, in Munich, so in many places. And in Italy, mainly in Università di Roma La Sapienza, and in Naples, in Napoli. So a lot of places. In USA, mainly it was Cornell University and also US Naval Observatory. So it is very good that astronomers collaborate and travel, and we are very actively internationally integrated. So this is one of our advantages, maybe, that helps also to develop our science and to put together joint projects, to make synergies of our knowledge, of our skills, and that's why it's easier to get good results and have achievements in science. So this was concerning the subjects of my research. Mainly it is active galactic nuclei. In astronomy, in the extragalactic astronomy, this is the most interesting thing because it is related to galaxy evolution, it is related to energy sources, energetic sources in the universe and namely in galaxies, and also different kinds of types of activity which we also investigate to understand how this activity appears. It is related directly to multi-wavelength astronomy because activity comes in every wavelength range, both optical, radio, X-ray, gamma ray, infrared, ultraviolet. So it is very interesting. The most complicated also, but in sense of interesting. It is complicated science, astronomy and our research, but it is very interesting because you have to deal with a lot of things in the universe, including your knowledge gained here in the school, in the university, from physics, from mathematics, from astronomy, where they study this, from chemistry also, sometimes from biology, from informatics. Computer science is very important now because we deal with big data. So another interest of mine is big data in astronomy. This is virtual observatories. In the world, there are many countries that develop virtual observatory project, and Armenia is among them. And Armenia also is part of International Virtual Observatory Alliance. And I am proud to tell this because we made a big effort and digitized Markarian survey, famous Markarian survey, which is probably our second famous astronomer after Victor Ambartsumian, our founder. And Markarian survey was so important that immediately a lot of spectroscopic data already digitized in digital form appeared in the world, and many people worked on this data. After all, in 2011, which means in the new era, not in Soviet times, we could include this survey, the digitized Markarian survey, in UNESCO heritage list. You imagine that from science, very rare, very few items are in UNESCO lists. Most of the UNESCO lists contain historical, cultural items, but not scientific. And in the world there are very few such things, and one of them is the item that we made, actually, this effort, and finally they accepted. We fought with UNESCO about 4 years because they required a lot of new justifications, some additional matters. So finally they accepted this. And then it worked as virtual observatory. A lot of new scientific papers appeared. So this is also one of my interests, one of my topics, the virtual observatories, or we call sometimes astroinformatics in general form. It includes astrostatistics, computational astronomy, modeling, etc. So a lot of such new developments that are related to computer science. What else? Probably I can say also some other matters, for example, archaeoastronomy, which is not my main topic of investigations, but I am very fond of also this field of astronomy, because Armenia is very rich with this, with archaeoastronomy. There are a lot of science of astronomical knowledge, of highly developed astronomical knowledge in Armenia from ancient times. Rock art, for example, ancient calendars, our ancient observatories like Zoraz Karer, which is very similar to Stonehenge in UK, and medieval astronomical knowledge by Anania Shiragatsi, etc. So we also developed this in our observatory recently, during the recent years, and this is also one of our directions. Now, speaking about the research departments, we have 9 research departments in the observatory, including theoretical ones, which do science just theoretically. Before we called it on the paper with pens or pencils and papers. Now this is done by computers, calculations, etc. So theoretically investigating the universe, knowing the physics, the mathematics, having the mathematical basis, and knowing the physics of the universe, we try to understand what happens there. The other thing is observational approach, and most of our astronomers are observers, of course. So they make observations themselves either, or they take data from already made observations from other telescopes, including automatic telescopes, which are, for example, space telescopes, and also ground-based telescopes from different times, from different wavelength ranges, from different geographical longitudes and latitudes, because it is very important. For example, when here is daytime, we cannot do observations, but on the other side of the Earth, it is night, and vice versa. When in the US, for example, they cannot do observation because it is daytime, then in Armenia we can make. So depending on the time of event, sometimes in the sky we have some event, for example, flare of some star or explosions or some variability. So we have to follow, monitor the object of interest continuously. This means that it is very important also to have telescopes at different longitudes, geographical longitude, not only latitude. Latitude also is important because, for example, from northern latitudes we observe northern sky and vice versa in the south. So everything is important to combine and make the overall picture of the universe. That's why different approaches and different mechanisms of investigations are being used in astronomy, including in our observatory, in Byurakan Observatory. So among the observational departments, I would name probably the young stellar objects, for example. They investigate young stars and stellar objects like Herbicare objects, nebulosities connecting to young stars. Then active galactic nuclei, astronomical surveys, which is my department. I am the head of this department. We call it astronomical surveys because with big amounts of data, exploring big areas of the sky, we try to select different kinds of interesting objects for further detailed investigations. So this in astronomy we call surveying the sky for some. These are in fact large search works, search projects. Then, as I said, we also created recently the archaeoastronomy and cultural astronomy department. So it is very different. In Byurakan Observatory we have a lot of different investigations and a lot of results. Every year we publish dozens of papers in different journals, including international ones, European Astronomy and Astrophysics, monthly notices of the Royal Astronomical Society, American ones like Astrophysical Journal and Astronomical Journal, and many others. We publish also books. Recently, for example, last year at the end, we published a book summarizing all achievements of Byurakan Observatory. It was dedicated to the 75th anniversary of Byurakan Observatory, which we celebrated last year. So the book is summarizing all results, achievements. We have the list of all astronomers who worked in Byurakan. We have the list of meetings and schools held here, books, etc., etc. A lot of information is given there. Some books we also published based on the proceedings of different meetings we organize in Byurakan. And by the way, some of the books were published by Cambridge University Press, the Astronomical Society of the Pacific in America, Roma University. So we worked in this way internationally. Byurakan Observatory is very active also internationally. A lot of collaborations with different countries. By the way, the best collaboration is with France. With France we have a lot of contacts and exchanges of scientists, especially young scientists. We have held 2 joint colloquia. We have many publications with the co-authorship of Armenian and French scientists. We have had many observations, joint programs of observations, etc. Many forms of collaborations. And most active it is with France. Also with Italy, with Germany, with USA, with Russia, with many other countries during all these years. Recently, in just 7 years ago, Byurakan Observatory got the status of International Astronomical Union, a regional office of astronomy for development. We call it ROD. So this region is called Southwest and Central Asia. And Armenia is the center, the coordinator of all these countries, from Turkey, from the European borders to Central Asian countries, Kazakhstan, Uzbekistan, Tajikistan, etc. So Armenia is like the leader of astronomy in this big region, and especially it is important that, you know, all these countries have different kind of conflicts between each other. It's not very easy, very, I would say, light region. This is probably the most complicated region, and the International Astronomical Union finally awarded this status to Armenia. There were a lot of applications from different countries, and each country had its own justification why it should serve as the center of this region. But finally they choose Armenia, and Armenia really, by scientific level, by traditions, by activities of organization of meetings and other activities. So I think we are really the best, and now we have already contact till 2027. So we started in 2015, and this is the second contract for 6 years, the next 6 years. So Armenia will serve also as the center. And it is the only status, such status Armenia has in any area, political, economical, sports, I don't know, cultural, scientific. It is the only such status. And astronomy, it means that we are really proud of astronomy, that Armenia is so active in astronomy. In Byurakan, we have 35 researchers, including 7 who are members of my team, my department, Astronomical Surveys. And from different countries, we have some new forms of staff working with us. So some work from abroad. For example, even the head of department, one of the heads of the departments, is professor from Frankfurt University. Some are foreign advisors. We call them foreign advisors. This is a status I just introduced in the observatory a few years ago. So we have about, not about, but exactly 6 foreign advisors. Then some young people come from time to time here to work and collaborate, especially very active interest from Iran is in recent years. I myself had Iranian students, MSc students, PhD students who defended and became professional astronomers. And really there is a big interest from many Iranian institutions, Tehran, IPM, then from Maraga Observatory, and etc. And not only Iran, of course, the regional countries, because as I said, we are serving as regional center, and from Georgia, even from Russia, Ukraine, which are not part of our region, but anyway, they also come very often here. When we organize summer schools for young astronomers and students, so many Russians and Ukrainians come together with our regional countries' representatives. Sometimes here we have also students from Europe, like France, Germany, Italy, and other European countries. So from time to time we also accept such students, though mainly the events are regional. We have both international summer school and have regional summer school. So in both cases, everybody is welcome, actually. And we invite very famous scientists as lecturers. It is important to have very good scientists as lecturers, because they also attract then good students to come and participate. Not only JW3ST, but I will speak about space telescopes that are projects from very big countries like USA, NASA, and European Space Agency and others. But Armenia, as a small country, has chance to participate, to use their data. This can be done either by collaboration with some of the teams which manage the projects, these telescopes, or just having access to the data, which sometimes are open. Not sometimes, but typically they are open after 1 year of when the project is presented and the observations are made. Then 1 year is given to the authors to manage this data, to reduce the data and to publish, make publications, and then it is open for the whole astronomical community. So in this case, you can use any data from these telescopes. James Webb is, of course, one of the new, but also, I would say, very important, and most of the important, probably, space telescopes that we expect to give results at least as many as Hubble, because it is coming after Hubble with a lot of better possibilities. I mean the technical, the equipment, of course. But at the present moment, I would also like to speak about Gaia, which is a European project, but also in collaboration with America. So Gaia is astrometrical observatory, and it made a revolution in astronomy, actually, because giving this astrometric data, they could change our astrophysics. It's interesting that many astrophysical parameters of different stars, and not different stars, but billions of stars, there are almost 2 billion objects in the Gaia catalogs, so we could derive from astrometric measurements. It's a very funny situation, because astrometry is one of the oldest areas of astronomy, and actually the modern observatories all are astrophysical mostly, not astrometry. Astrometry is considered as one of the old, already maybe not used branch of astronomy. But now Gaia proved that astrometry can really provide a lot of data for development of astrophysics. And the picture of our Milky Way, the dynamics, everything now is done based on Gaia data. A bit before, in the beginning of 2000s, and now it is continuing, another Sloan Digital Sky Survey is by American universities, and this is extragalactic. Also, we use very widely Sloan data to investigate, to compare. We have a lot of possibilities of access to this data, and many of our results are done based on Sloan data, STSS data. So I would say that it is very important, it is very nice that astronomers can exchange of data. The data are so many that I think that even the whole population of the Earth, if they were astronomers, anyway, the data will be enough for everybody to study, because the universe is very big. As you know, in astronomy also, as everywhere, when somebody puts money, he or she dictates all conditions. So Armenia can participate anyway if we have some, for example, smart idea of using JWST or any other space telescope or ground-based telescope to give good results. I myself once succeeded this way, proposing an observing project for Spitzer space telescope. Spitzer was infrared space telescope, one of the big projects of NASA, and they accepted with very high estimates, with high marks. So this project was done, and then we published papers in Astronomical journal and Astrophysical journal with American co-authors. So it was very nice to have at least once succeeded in such international projects. The same is needed with JWST to more actively participate there. For me, most important are galaxies, because it's my field, and namely, in this case, infrared galaxies. As JWST is focused on near and mid-infrared, so it is for the first time that we go so deep in infrared. And then we can, infrared is important to investigate star formation in galaxies. So the best hope probably would be to understand the star formation and especially starburst processes. We call starburst when the star formation rate is very high. So in this case, we understand how the universe developed during its history, and when the star formation process started, when the starburst reached its peak, and then some quenching process started in galaxies. So this is very important for the evolution of the whole universe, and the extragalactic astronomy especially is important here to support the understanding about the whole universe. So, and I believe that JWST data and projects will do this, will finally achieve this. The origin is not yet understood, and the physicists have thought of some theory which we call quantum gravity, which is the beginning, the starting condition of the universe, when nobody can describe anything, the physics doesn't work there. After quantum gravity, okay, we have very nice scenario of development of the universe. So that's why the beginning is a little bit different from those other processes that astronomers maybe really can understand and investigate. But the beginning and the early stages are also investigated by theoreticians, by cosmologists. Cosmologists just make calculation, make their physical understanding, apply their physical understanding, and actually extend also our understanding of physics due to cosmology, because those conditions that we have in the universe, you can never make on the Earth. On the Earth, our laboratories are very limited, very restricted compared to the universe. So the universe is the biggest and the most complete laboratory to investigate everything, the whole states of materials, matter, and everything. So that's why astronomy is a very interesting science, and probably the leader of all natural sciences. We get up to continue. We always think about our problems, our research. You never have rest. Your brain never has any rest. This is a fact for all scientists, I think. But it is very, maybe not very easy to live this way, but very interesting to live. And interesting doesn't mean easy. Interesting is when it is complicated, when it is compound, when it is confused. All this is for us probably our life, and this main part of our life. Thinking, trying to find something. As Einstein said once, scientists are like children. They always ask questions. But the difference is that children expect answers from others, but scientists cannot expect from anybody. So they try to answer themselves all these questions. But we have to ask questions and then try to answer. So this is the interesting thing of our life. We already organized even a European annual meeting here. Armenia is an exception among all countries, because Armenia is even not in Europe, but we are part of European Astronomical Society, and in 2007 we organized the European Astronomical Society annual meeting, the big meeting in Armenia. Then also International Astronomical Union meetings, etc. So a lot of different types of activities. Now we also run a lot of educational and public activities, events, a lot of events. Every year we have 25 to 30 events here. Right now, for example, we will have now 4 events, one after each. The first one is Astronomy and Astrophysics Journal Board of Directors meeting, which we will have on 11th of this month. Then camp for Artsakh pupils. Then Artsakh students will come here for summer school. And then a Byurakan Science Camp for all Armenia. It is already the 8th one. We have regular programs. In September, we have Byurakan International Summer School for professional astronomers, young astronomers and students. And then international meeting, which we dedicate this time to space sciences and technologies. And this way, a lot of already this year, this is half of the year, we already had 15 meetings, 15 events.